Welcome students to this video. We are going to be looking at factoring two different types of binomials, okay? Now so far we've looked at factoring trinomials with a lead coefficient of 1, trinomials without a lead coefficient of 1. Now we're going to look at factoring two different types of binomials. Now, today in this video we're only going to study one type, and it's the type called the difference of perfect squares. Okay, so I'd like you to write this heading down: factoring the difference of perfect squares. Factoring the difference of perfect squares. Now remember, I go fast in these videos. You're going to have to pause the video a lot throughout the video, and that's totally normal. Okay, all right, here we go. Here are the steps for factoring the difference of perfect squares. And by the way, when you write this heading down, go ahead and put today's date right here, whatever the date is. That's very helpful in your notes, okay? So write the heading and then write today's date, all right? Okay, moving on. Here are the steps when you are factoring the difference of perfect squares. Here we go. Step 1, like everything else, always pull out what's common first. Step 2, make sure that you have a binomial in which the first term is positive and the second term is negative. If you don't have that, you need to rearrange the terms, or you can't factor it. One of those two scenarios, okay? All right, continuing on. Step 3, make sure both terms are perfect squares. And I'll explain later what that means. And then factor. Okay, so here we go. Let's go ahead and take a look at 5 problems. These are pretty simple, so we're going to go pretty fast, all right? Here we go. All right, first of all, let's factor this polynomial. Now, first of all, pull out what's common. Well, there's a 1 here and a 16. No number really goes into 1 and 16 evenly. Do both terms have an x? No, so there's no x's you can pull out. Step 2, make sure you have a binomial, which we do. Here's one term, here's another term. Binomial means two-termer, and we have two terms right here. And the first term should be positive, and it is, and the second term should be negative, and it is. So we're totally good there. Step 3, make sure both terms are perfect squares. Now a perfect square means this: it means you can take the square root of it. Now, can we take the square root of x squared? Definitely. The square root of x squared is x. How do I know that? Because x times x is x squared. So this is a perfect term. Now, you've been taught pretty much your whole mathematical life that you cannot take the square root of a negative number. That's true, unless you're using imaginary numbers, and we'll get to that later. But when I say in step 3, make sure both terms are perfect squares, I'm saying to forget the sign. Don't worry about the sign. Just look at this term without the sign. Is 16 a perfect square? Well, sure it is. The square root of 16 is 4, right? Because 4 times 4 equals 16. So, I have a question for you. Are both of my terms perfect squares? Yes, they are, so we're good. So now we factor. And there's really no steps to give you on the factoring part. It's just memorizing this procedure. You put two little parentheses. In your head, you take the square root of this. And the square root of your first term is x, so you put an x here and an x here. Then in your head, you take the square root of this term, which is 4, and you put that here, and you also put it here. Isn't that easy? And then you always make one of your second terms positive and make one of them negative. Now, if you want to turn these two parentheses around and put your x minus 4 first and your x plus 4 second, that is totally acceptable, okay? Absolutely no problem with that. All right, so there we go. Pretty simple. Factoring the difference of two squares. And by the way, do you see why it's called the difference of two squares? You're subtracting, so that's a difference, and you have two perfect squares. And that's why we call it factoring the difference of perfect squares. Okay, moving on to the next problem. You can work ahead or watch me. Pull out what's common. Well, I've got a 1 here and a 36. No number goes into 1 and 36 evenly. I have 4 y's here and no y's here, so I can't pull out any y's. Number 2, make sure you have a binomial, which I do. Make sure your first term is positive, it is. Make sure your second term is negative, and it is. Step 3, make sure they're both perfect squares. Well, do I know the square root of y to the fourth? Sure I do. It's y squared, because y squared times y squared is y to the fourth. Do I know the square root of 36? Sure I do. It's 6, because 6 times 6 is 36. So both of these terms are perfect squares. So step 3 is done. Now just factor it. So you put two little parentheses. Take the square root of y to the fourth in your head. The square root of y to the fourth is y squared. So I put a y squared here and a y squared here. Take the square root of 36 in your head. The square root of 36 is 6. Put a 6 here and a 6 here. Make one positive and make one negative. And you're done. It's that simple. Okay, moving on to the next problem. Okay, now step 1 says pull out what's common. I cannot pull out, nothing that I know of goes into 4 and 81. And I've got x's here and y's here. Do I have any x's over here? No. Do I have any y's over here? No. So I cannot pull out any x's or y's. Now here's where it gets a little interesting. Now you say, well, Mr. Earhart, pull out a negative sign because you taught us you never want your first term to be negative. Okay, that's fine. Let's pull out a -1. You can do that. There's nothing wrong with that. And if you do that, you're left with a +4 and a +81. Now watch why that is. A -1 times 4 is a -4x squared, and a -1 times 8, or 81, excuse me, put a little 1 right here. A -1 times 8, +81 is a -81. But now here's where this thing becomes, are you ready for the answer? The answer to this is not factorable. Not factorable, and here's why. Look at step 3, or look at step 2. Make sure that you have a positive first term and a negative second term. Well, your first term is what? Positive. Your second term is what? Positive. There's nothing you can do to change that, guys. Okay? Now I will say this, if you ever have a negative first term like that and a positive second term, you can just swap those around and put your 4 first and your -x squared second. You can do that, but that's not going to help here, guys. Both of your terms are positive and positive. So there's no way you can rewrite this so that your first term is positive and your second term is negative. So you cannot factor this binomial. Cannot do it, okay? All right, let's continue on. All right, let's pull out. Notice now we have the same problem, just change the sign right here. Pull out what's common. Well, there's no number that I know of that goes into 4 and 81. And there's x's here, but there's no x's over here. There's y's here, but there's no y's over here. So you can't pull out any x's or y's. So really there's nothing common you could pull out. Now you could pull out a -1, but really instead of that, notice step 2 says make sure you have a binomial in which the first term is positive and the second term is negative. Well, I'm going to swap these two signs around, or these two terms around. I'm going to put my 81y to the fourth first, since it's positive, and I'm going to put my -4x squared second, and now I've accomplished step 2. I have a binomial. My first term is positive, and my second term is negative. So we're good. Now, by the way, if you chose to pull a -1 out like this, and then make your 4x squared negative, and your 81y to the fourth, excuse me, if you chose to pull out a -1 and make your 4x squared positive and your 81y to the fourth negative, I will give you full credit for that on a test as long as you go ahead and factor this out the right way. So if you did that, I have no problem with that. To me, it's just easier to swap the two terms, okay? All right, moving on to step 3. Make sure both terms are perfect squares. Well, do we know the square root of this term? Well, sure we do. The square root of 81 is 9, and the square root of y to the fourth is y squared. I mean, 9 times 9 is 81, and y squared times y squared is y to the fourth. So yes, most definitely we know the square root of this term. Do we know the square root of this term? Well, sure we do. The square root of 4 is 2, and the square root of x squared is x. 2 times 2 is 4. X times x is x squared. So yes, I do have two perfect squares. So now we're just going to factor. Put a couple little parentheses. the square root of 81y to the fourth. Do that in your head. You'll get 9y squared. So we're going to write that here, and we're going to write that here. And then take the square root of 4x squared in your head. The square root of 4x squared would be 2x. So we're going to put a 2x here and a 2x here, and then make one positive and make one negative. There we go. You did it. Okay? All right, moving on to, I believe, our last problem. All right, and we're finished. So here we go. Okay, step one, pull out what is common, and let's go ahead and do that. Notice I can pull out what number goes into 3 and 75 evenly. I'm going to go ahead and pull out a negative sign this time. You can do that. I'm going to pull out a negative 3 because 3 goes into 3 and 3 goes into 75. Also, I have A's here but no A's over here. However, I've got an X here and an X here, a Y here and a Y here. So I'm going to pull out an X and a Y also. And let's see what we're left over with. We should be left over here with A squared. Let's see if I'm right. Negative 3 x y times a squared would be negative 3 a squared xy. Over here, I'm going to put a negative 25. Let's see if I'm right. Negative times a negative is positive, so that's good. And 3xy times 25 would be 75xy. So we're doing great. We pulled out what's common. Now, step two, make sure you have a binomial, which I do. Here's one term, here's the other term. Make sure you have a binomial in which the first term is positive, and it is, and the second term is negative, and it is. So we're totally good. Step three, make sure both terms are perfect squares. Well, I know the square root of a squared. It's a. And I know the square root of 25. It's 5. So both of these are perfect squares. So step 4, factor. Bring down your negative 3xy, which is what you pulled out earlier, and then put two little parentheses. What is the square root of a squared? What's a? So put an a here and an a here. What's the square root of 25? 5. So put a 5 here and a 5 here. Make one positive, make one negative. There we go. We did it. We factored this binomial right here, and we could do that because it was the difference of two perfect squares, or the difference of squares. Okay? All right. I hope this video has been a help to you guys. Please continue to work hard on your math and work hard on your factoring.